Hello, period 8 math. All right, so today we're going to do a quick review of compound probability and different types of problems that come with compound probability. And then I'll introduce you to the activity and practice problems we're going to be working on for the next couple of days. All right, so let's get started. Hopefully you have these notes downloaded into Notability already and you're ready to jump in with me. So as a reminder, when we are finding compound probability, we're going to do a couple of different things, and I wrote out your list of steps right here. So first, you're going to find the probability of each event, right? Compound means that there's two or more events, just like a compound word has two or more small words in it. Compound probability has multiple events. And I believe all of the problems we're going to do just have two events. So that means you're going to have for each problem two fractions that you're going to find, okay? One fraction represents each event. And you're going to multiply those probabilities or those fractions times each other. And then in the end, you need to either reduce your fraction, okay, all the way down to lowest terms, or you can divide to find the decimal or percent. All right, so let's get started. In example 1, it says, find the probability of flipping a coin which lands on heads and rolling a number bigger than 4 on a number cube. All right, so we have our two events. I find it helpful to do a little highlighting, okay? So we're finding the probability of flipping a coin, right, landing on heads, so that's 1. And then our second event is rolling a number bigger than 4 on a number cube. Okay, so those are our two events, the green one, flipping heads on a coin, and the yellow one, rolling a number bigger than 4 on a number cube. Okay, so you're going to have to do some careful reading also when you do this, because particularly for this one, a number bigger than 4. All right, so let's start with our green event, flipping a coin and landing on heads. Well, we can remember from our videos over the last 2 days that what we do is we set up our proportion to be the number of possible outcomes, right? So the possible outcome of landing on heads, there's only one side of a coin that is heads. So that means it's just going to be a 1 for the top number of our fraction. The total number of things is the total number of things that are sides, or the total number of marbles in a bag, whatever it might be. So the total number of sides of a coin are 2. So the probability of flipping heads on a coin is 1 out of 2. All right, and then we're going to find our probability of our yellow event, the one about the number cube. So rolling a number bigger than 4 on a number cube. Well, the total possible outcomes, so the numbers that are bigger than 4, remember a number cube has 6 total sides. 1, 2, 3, 4, 5, and 6. And you can see here's the 4 on this number cube here. Here's the 4. There's only 2 sides that are bigger than 4, the 5 and the 6. All right, so we only have 2 sides that are bigger than 4, but we have 6 total sides. All right, so 2 over 6 is our probability of rolling a number bigger than 4 on a number cube. All right, so we found the probability of each event. Now we're going to multiply those probabilities together. All right, now when we multiply a fraction, guys, we just multiply straight across. So 1 times 2 is going to give us 2. 2 times 6 is going to give us 12. So we've just taken our fraction and multiplied our two fractions. We multiply fractions straight across. All right, so now I've got 2 over 12. So I'm just going to move that down here for myself. So 2 out of 12, I can do a couple things. I can reduce that fraction, or I can divide to find the decimal or percent. So this fraction's a really easy one to reduce. 2 goes into itself once, 2 goes into 12 6 times. So that's it. My probability is 1/6, or 1 over 6. 1 out of 6 times, I'm going to be able to flip a coin, land on heads, and roll a die and get a number that's bigger than 4. Okay, so if I try that 6 times, the likelihood that I'll get that is just 1 out of those 6 times. All right, let's try our next problem. Okay, there's one other quick thing we want to just review really quick. That these are called independent events, independent probability. Independent, sorry, couldn't spell and talk at the same time. So this one is independent because when I flip a coin, it doesn't impact the rolling a number cube at all. No matter what I flip on my coin, it's not going to change what's going to happen when I roll my number cube. So those are independent. They don't depend on each other. They're not going to change. Okay, but then in our next problem here, these are called dependent events. Okay, so these are dependent, and we're going to see a difference of objects not being replaced. So that means that the first probability is going to change the second probability. All right, so let's take a look at this example together. So we have 2 marbles are randomly drawn from a bag that contains 3 red, 2 blue, 4 green, and 1 yellow marble. Find the probability of drawing a blue marble, not replacing it, and then drawing a second marble that is red. All right, anytime, guys, that you see these words, not replacing it, I want you to highlight that, underline it, circle it. It's important. Okay, that means that they are dependent events. All right, they are going to change when something is not being replaced. Okay, so we're going to look at our checklist here. And our checklist is the same as before, where it says find the probability of each event. All right. But in step 2 here, it says that if the object is not replaced, then it decreases the totals. So let's show you what that means right here. All right. So the first thing we're going to do is add up our totals. Because in order to get our total number of things, we have to count these up. So I've got 3 plus 2 plus 4 plus 1. And I have the same picture right above, so you could also just count the marbles, but adding them up will be just as quick. All right, so 3 plus 2 is 5, plus 4 is 9, plus 1 is 10. So I have 10 total marbles, right? The total number of things is 10. So now let's take a look at what my first event is. So the first event is find the probability of drawing a blue marble. All right, so there's my first event, drawing a blue marble. Well, I have 2 blue marbles. All right, so the probability of drawing a blue marble is 2. So there's 2 blue marbles out of the total of 10 marbles. All right, so then let's find the probability of our second event. So we're not going to replace that blue marble. We've taken this blue marble out of the bag. It's gone. I shouldn't do that in that color. Let's see, if we were to do, let's say, just like black. Taken this blue marble out of the bag. It's totally gone, okay? And now I'm going to find the probability of drawing a second marble that is red. All right, so that's my second one. So now my total number of marbles, if I count right here, if I count over here, 1, 2, 3, 4, 5, 6, 7, 8, 9. My total number of marbles has decreased because I got rid of this blue marble. So now my total number of marbles, guys, is 9. Okay, I have 9 blue marbles. But if I look right here, I have 1, 2, 3 red marbles. So my possible outcomes of drawing a red marble is 3. So 3 red marbles out of a total of 9 marbles. All right. The probability of this first event, since I wasn't replacing it, changed the probability of the second event. So they are dependent. All right, so we have found the probability of each event, and then we said if the object is not replaced, it decreases the totals. So now we're going to multiply those probabilities times each other. All right, so remember, we multiply straight across. 2 times 3 is going to give me a 6, and 10 times 9 is going to give me 90. So I have a couple of options here. Remember that I've done that, I can reduce my fraction or I can divide to find the decimal or percent. So 6 and 90, 6 goes into 90 evenly. If I just divide 90 divided by 6, I'm going to get 15. So that means that 6 goes into itself once and it goes into 90 15 times. Okay. Now the other option is that I can just divide, right? So I would divide 1 divided by 15 or 60 divided by 90, and I would get 0.067. So what I really get is 6.7%. Okay, any one of these answers is correct. As long as your fraction is reduced, your answer is correct. Or you can divide, get a decimal, and change it to a percent. Any one of these three answers is correct. All right, so we're going to look at our next example problem here together. And in this problem, guys, we're going to do the same thing, except now it's going to change the totals of both the numerator and the denominator. So let's jump in. This problem is very similar with just one subtle difference, just to show you how it can be a little bit different. All right, so 2 marbles are randomly drawn from a bag containing 3 red, 2 blue, 4 green, and 1 yellow. Find the probability of drawing a blue marble, not replacing it, and then drawing a second blue marble. All right, so that's why this one's going to be a little bit different. All right, so again, we're going to just add these up, right? And you probably remember, but just to remind you how to do it, we just add up our numbers to find our total. So 3 plus 2 plus 4 plus 1 is going to give me 10 total marbles. Okay, so now I'm going to find the probability of drawing a blue marble. So let's do that first. So the probability of drawing a blue marble, since there are 2 blues, I have the probability of 2 blues over 10 total marbles. Now I'm going to multiply that probability times my second probability. All right, so if I look at my second probability, remember I'm not replacing. So that means that I took this blue marble is now gone, right? I've gotten rid of that blue marble. So now if I count up my totals, I have 9 total marbles, but it's also asking me to draw a second, oops, that's not what I meant to do, to draw a second blue marble. Right? So I'm drawing a second blue marble. So I'm going to look, how many blue marbles do I have now? Well, I got rid of 1, so that means I only have 1 blue marble left. So it's no longer 2 blue marbles like it was in the first one. I also have to decrease my second blue marble because it's only 1 blue marble is only what remains. Okay, so now I have found the probability. I have not replaced, so I've decreased my totals. And I'm going to multiply my probabilities. So 2 times 1 is 2. 10 times 9 is 90. All right. And so now we can reduce our fraction. And 2 goes into itself once. 2 goes into 90 45 times. Or remember that you could always take your fraction and divide to get your decimal, and it would be 0.2 repeating. So that would be 2.2%. Okay, remember any one of these three are your correct problem, your correct answer. All right, so let's do one of these together. So a letter of the alphabet is chosen at random and then a coin is flipped. What is the probability of choosing a letter from the word math and then getting tails? Okay, so these are going to be a little different. They're not just all going to be your ones about number cubes. There are going to be some of those, but some of these are a little trickier. So you've really got to read and think. All right, so my first event is choosing a letter of the alphabet. How many letters are there in the alphabet? Well, if you can't remember, there are 26 letters in the alphabet. And then I'm choosing the probability of choosing a letter from the word math. All right, so from this word math. So how many possible outcomes are there in the word math? Well, there are 1, 2, 3, 4. There's 4 different letters. So that means that for my first event, I have 4 possible letters from the word math out of a 26 total possibilities. There are 26 letters in the alphabet, and there's a possibility of choosing one of the 4 letters, right? So 4 out of 26. And I'm going to multiply that times the possibility of getting tails. So anytime we're flipping a coin, the probability of flipping one or the other on a coin is 1 out of 2. All right. Okay, so you're going to do the same thing we've been doing. We multiply straight across. 4 times 1 is 4. 26, sorry, 26 times 2 is going to give us 52. So we can reduce our fraction, or we can divide and figure out our decimal. So 4 divided by 52 is going to give us 0.16, which is going to equal 16%. Okay? All right. So guys, for the remainder of class, I know we probably don't have too much time left, but I'll have you set a timer. And I just want you to work on the practice problems in the packet, work on the practice problems in this packet. So you're going to work for about 20 minutes, or solve like 5 more problems, whichever comes first. Don't work beyond math class time, okay? You're going to turn all these problems in on Friday, but we're going to have more time to work on these in class and complete them. So it's okay if you skip around or if you try one and realize you're kind of confused, okay? Because we're going to have time to work on these together, probably tomorrow, but definitely Friday, okay? All right, guys, so get working. And there's nothing to submit today. You do not have to submit anything. We will check in about all of this again tomorrow. All right, guys, talk to you later. Bye.